Peace and prosperity. This video will cover external ballistics after a cartridge is deployed from a firearm. Today I'm going to break down three major external ballistic concepts: trajectory and sight alignment, gyroscopic spin drift, and vertical angle shooting. My goal is to explain these concepts using everyday analogies so that any client walking into a gunsmith shop can easily understand them. First, let's look at trajectory and sight alignment. Trajectory is the curved path a bullet travels through the air after leaving the muzzle. Gravity acts on the bullet the millisecond it leaves the barrel, creating a dropping arc. Sight alignment is the straight line of sight your eye takes through the scope or the iron sights to that target. Think of it like this. My staff represents the straight line of sight through your sights pointing right at that bullseye. This battery represents the bullet. A bullet doesn't fly flat like a laser. The barrel is actually angled slightly upward relative to the scope. The bullet starts below the scope line, rises up to cross the point of zero, peaks, and then drops back down through that line of sight at a specific distance. This is the determination of the firearm and sight's zero. As for flight and accuracy, because the bullet travels in a curved arc, while your line of sight is perfectly flat, you will shoot too high if your target is closer or too low if your target is farther than your zero distance. As a gunsmith, I highly advise gun owners on choosing the right zero distance based on their specific cartridge and how they shoot. We talk about maximum point blank range so they can hit a target without adjusting their dials, ensuring that their line of sight and bullet arc work perfectly together. Concept number 2 is gyroscopic spin drift. When a bullet travels down a rifle barrel, the twist in the barrel makes the bullet spin incredibly fast to stabilize in flight. However, as air hits the nose of the spinning bullet, it causes a tiny aerodynamic tilt. Combined with the spin, this forces the bullet to drift slightly sideways. I have a simple coin here. When I spin it on the table, it doesn't stay perfectly upright in one spot. As it slows down or interacts with air, it begins to wobble and crawl sideways across the table. A clockwise twisting barrel makes a bullet drift continuously to the right, even if there is absolutely zero wind. So I'm gonna demonstrate real quick. At short ranges, you won't notice it. But when you are shooting at extreme long distances, like 500 yards in the Marine Corps rifle qualification shoot, up to 1,000 yards, like Marine snipers proficiently train at, spin drift can put a bullet several inches off target completely on its own. When a gun owner wants to build a long-range precision rifle, I explain how barrel twist rate affects the specific bullet weight. I teach them to check their ballistic calculator applications or dial in a few clicks of left windage to cancel out that predictable right-hand spin drift at long distances. Finally, let's talk about vertical angle shooting, which happens when you are shooting sharply uphill or downhill. The key term here is slant range. The actual distance your laser rangefinder measures directly to the target, but gravity only affects the bullet over the horizontal distance. Look at this triangle. If a deer is sitting way up on a mountain peak, the long diagonal side of the triangle is the slant range your eyes see. But the horizontal ground underneath is a much shorter distance. Gravity only cares about the horizontal distance the bullet travels on the earth. Because the horizontal distance is much shorter than the diagonal line, gravity has less time to pull the bullet down. If you aim the full diagonal distance, you will completely overshoot and the round will fly right over the target, regardless of whether you are aiming uphill or downhill. I help clients prevent this by recommending angle compensating laser rangefinders. I explain the math simply. Aim for the horizontal distance, not the look line distance. If the rangefinder says 400 yards on a steep hill, but the true horizontal distance is only 320 yards, I tell my clients to hold the dial for 320 yards so they can take a clean and technical shot. In conclusion, understanding these three concepts helps any shooter transition from guessing to knowing exactly where their round will land. Thank you all for tuning in and watching, and have a blessed day.